Now we'll look specifically at the ANOVA-F test that was kind of briefly mentioned on the previous page. But on the previous page, we just said this is the name of the test that we will use, and these are two examples of when we would want to use it. But we don't know anything about it yet until this page and the coming pages. The first step would be state the hypotheses. So we'd kind of seen that before, but it was only when we had one mu or two mu's to compare. As before, the null hypothesis is a statement of no difference or no treatment effect. So it would be that even though there are more than two mu's here, because there are more than two populations, the null hypothesis still says that all the mu's are equal to each other. There's no difference. They're all the same, no matter how many there are in your example. Unlike previous tests where we had three options for the alternative hypothesis, greater than or not equal to, and then et cetera, et cetera. In the ANOVA-F test, there is no choice. The alternative hypothesis just says not all the population means are equal. So pretty much saying that the null hypothesis isn't true. Because the null hypothesis is saying that all mu's are equal to each other. And the alternative hypothesis is just saying, no, that's false. At least one of them is not equal to the rest, basically. And it's because there are too many things to specify. We don't know how many mu's there are. So it'd be, whereas before the alternative hypothesis, when there were two mu's, was that one is bigger than the other, or it's the other way around. Instead of the first being bigger than the second, the first is smaller than the second, or they're just not equal. There were only three options. We actually listed it out. But now that there are who knows how many populations, K of them, it's kind of impossible to list how many options there are as far as which one's bigger than the others and comparing lots of mu's and lots of populations. So we just say they're not equal, just to keep it simple. There's too much going on here. So the alternative hypothesis would just be always that not all population means are equal. Or equivalently, the alternative hypothesis would be at least one population mean is different from the others. We do not write the alternative hypothesis with symbols. Why not? And like we kind of mentioned above, because there are so many ways for it, for mu1, mu2, mu3, mu4, and on if there are more, to differ. For example, it could be that just mu1 is not equal to mu2, also not equal to mu3, also not equal to mu4, or three of them are equal, mu1 equals mu2 equals mu3, but mu4 is different, or mu1 is greater than mu2, but mu2 is equal to mu3, and mu3 is not equal to mu4. And just imagine how many combinations there are of greater thans and less thans and not equal tos in there. There would be so many options, it'd just be crazy to list them all. And that's just a few of them that they listed. So for this reason, we simply write the alternative hypothesis is that not all means are equal. We are not specific about the way in which the means might be different. It depends on the situation, and as we do the data analysis in that specific situation, we'll see more about it. Okay, now let's look at this example. The one we saw before is academic frustration related to majors. So we said we were going to compare business majors, English majors, math majors, psychology majors, and they all had a sample size of 35 students from each of those majors. So we'd get 4 independent samples. The correct hypotheses for our frustration examples are, first, the null hypothesis is that mu1 equals mu2 equals mu3, where mu is the mean frustration score for the population of all students in that major. So the null hypothesis is saying that the frustration level is the same no matter which of those 4 majors you're in. But the alternative hypothesis isn't going to specify which one they think has a higher frustration levels than the other. It's just going to say they're not the same. So alternative hypothesis would be that the mu's are not equal, or we could just say that at least one major has a different mean frustration than the others.